To understand the impact that Dr. John Kohl has had on astrophysics and space travel, one needs to know only this. John's invention, the ultraviolet coronagraph spectrometer, is on display at the Smithsonian Air and Space Museum. John, the College of Natural Science and Mathematics outstanding alumnus, has done as much to impact the study of solar physics as anyone in the world. His UVCS instruments were carried into space on rocket flights, 5 space shuttle flights, and the International SOHO satellite missions. It's the gold cylinder. First, a science lesson. The extended solar corona is part of the solar atmosphere that can be seen in visible light from the Earth during a natural solar eclipse. This is the region where the electrically charged gas called the solar wind is accelerated out of the sun, filling interplanetary space. It's also where coronal mass ejects and solar energetic particles are produced, causing geomagnetic storms, power surges, and potentially damaging radiation to astronauts and their equipment. John's ultraviolet coronagraph spectrometer allows ultraviolet light from this region of the solar atmosphere to be spread out into a spectrum, so the light from many different electrically charged atoms can be measured and analyzed. Measurements from John's invention essentially turned the theoretical physics understanding of this coronal region upside down. The UVCS came out of John's PhD background in spectroscopy at UT. Having earned a master's in physics at Toledo in 1967, he was working toward becoming the very first physics PhD grad in university history, which occurred in 1969. His research demonstrated that the curve-fitting techniques being widely used at the time to infer atomic lifetimes of multiply charged ions excited by what was known as the beam foil method could lead to unreliable results. Harvard took immediate notice. John's mentor, John Turin, was thrilled. Physics professor Pete Jones told John not to give up and that the people at Harvard would let him know if he should leave, so just keep trying. John was at Harvard's Smithsonian Astrophysical Observatory for nearly 44 years until he retired 2 years ago. John was a student at Muskingum College when John Glenn became the first man to orbit Earth. Amazingly, when Glenn returned to space in 1998, he carried our awardee's invention. John's UT days not only included great research, but a great wife. Nancy Middleton taught in UT's community college and worked in the computer center. They were introduced by mutual friends and celebrated their 50th wedding anniversary in August this year. They are the parents of 2 children, Betsy Anderson and James, as well as 4 grandkids. 3 other bits about Jack's grandfather, who splits time between Boston and a cottage in Maine. You might recall that there was an unscheduled spacewalk in 1997. It's because the satellite carrying John's instrument was not deployed correctly. Astronauts ultimately went out in the shuttle bay and grabbed the satellite with their hands, locking it back down. Among his many accomplishments, John was responsible for developing an ion beam experiment to measure electron excitation cross-sections, and he also provided the first direct evidence for the presence of boron in the Sun, providing an important benchmark for theoretical values for light nuclide formation by galactic cosmic ray spallation. Simply put, Dr. John Kohl is a legend in solar physics. He's the College of Natural Science and Mathematics Outstanding Alumnus in 2015.